People have done so for a very long time, imagined how life might be different on other spheres. As a result of the James Webb Space Telescope, the most remarkable telescope, that question may finally exist to be dissected, keeping in mind that Proxima is the closest star system to Centauri, which is just 4 light years. Aware researchers have observed a few unmistakable characteristics of one of the planets in Proxima B's system. These artificial irregularities, lights that dazzle the mind, have no explanation in normal science. But what do these lights indicate? The existence of intelligent life? We are joined by the James Webb Space Telescope in examining this possibility. The startling discovery of what appears to be city lights with the power to alter everything raises a profound question. The only life that we are aware of at the moment has existed on Earth, but people have long questioned whether others exist to carry out such an interstellar feat. Jill Tartar, an American space expert, along with Thomas Pearson, started the search for intelligence from other planets with the 1984 SETI project. The foundation aims to collect space-origin radio waves. Radio transmissions can travel far, increasing their likelihood of being picked up by the radio specifically. By the 42 one-of-a-kind Allen telescopes array in the California Sierra Nevada mountains. Lately, however, no definite signal from another planet has been discovered. After that, the launch of the James Webb Space Telescope successfully aided in the investigation of a variety of exoplanets that orbit faraway stars. Floating approximately 1 million miles from Earth, it is the largest telescope ever built, and is equipped with incredibly delicate instruments that might be able to make significant discoveries. A while ago, there were no known planets beyond our planetary system. Since then, however, more than 4,000 exoplanets have been discovered, encircling a variety of stars. According to NASA, there may be millions of stars with exoplanets in the universe. Early indications of life occurring outside of our solar system may be found on other planets. During the Galileo spacecraft's course to Jupiter, its instruments were turned back toward Earth and detected a clear sign of vegetation by observing the red edge of the planet. This vegetation red edge is a biosignature made up of a combination of reflected red and infrared light by plants. For example, an Earth-like planet surrounded by a jungle ought to have a sturdy and visible red edge signal. The JWST James Webb Space Telescope will measure the red edge of distant objects. Habitable planets that look like Earth-round stars that could sustain life may offer crucial insights into conditions beneath an exoplanet's atmosphere. When light passes through a planet's atmosphere, the JWST might detect missing frequencies that indicate the presence of certain molecules. These can then be observed through spectroscopy. Molecules and particles in an atmosphere absorb specific frequencies of light, creating unique fingerprints. This method can be used by the JWST to determine an atmosphere's composition and assess whether life is possible. Planets the size of Earth, with atmospheres composed of nitrogen, carbon dioxide, and oxygen, could host life by searching for compounds not commonly occurring naturally. We may detect intelligent life. For instance, chlorofluorocarbons, CFCs, man-made compounds used in cleaning and refrigeration, would almost certainly be detectable. If Earth were observed by extraterrestrial astronomers, its CFCs could reveal industrial activity. If JWST detects CFCs in a planet's atmosphere, that would be a definitive sign of technological advancement. Still, life on exoplanets may not look like life on Earth. In fact, it might not even resemble it. Even ordinary organisms, such as extremophile species that thrive in harsh environments, could appear alien. These organisms, primarily microorganisms, can withstand extreme heat up to 250 degrees Fahrenheit, or acids with a pH of less than 3, because Earth-like planets are more likely to support life compared to those with extreme temperatures or acidity. It's wise to focus first on potential candidates with more Earth-like conditions. That includes planets with temperatures that allow liquid water to exist both in orbit and on their surfaces. Our Sun is classified as a stable yellow G-type star. Such stars are more restricted in number and typically have shorter lifespans. However, in our universe, more prevalent red dwarf stars, though DMAR, have cooler temperatures and longer lifespans. This longer time frame permits the growth of life and the evolution of complex creatures. Located 40 light-years away from Earth, the TRAPPIST-1 planetary system is one of JWST's main targets. It orbits a calm red dwarf star and hosts 7 Earth-sized rocky planets, 3 of which are in the habitable zone. These planets may have liquid water on their surfaces. Despite their smaller size and mass, and the star's lower temperature compared to our Sun, TRAPPIST-1 emits light similar to Earth's Sunday glow because of their close orbits. These planets present the most promising opportunity to locate city lights. Proxima Centauri may also host life outside our solar system. It is a red dwarf star 4.25 light-years from the Sun. It is much smaller and dimmer than the Sun, so any planet depending on it would have to orbit much closer to sustain life. In August 2016, scientists discovered a planet in the habitable zone with 1.3 Earth masses. This Goldilocks zone receives just the right intensity of light for liquid water to exist. Proxima B orbits Proxima Centauri. However, it is possible that Proxima B has no atmosphere. This may be due to its extremely close orbit, just 4.66 million miles away from its star, which exposes it to powerful solar winds that could destroy its atmosphere. Nonetheless, Proxima B receives sufficient sunlight for temperatures and liquid water to function similarly to Earth because of its distance from the star. Proxima B is believed to be tidally locked, always showing the same face to the star. Much like the Moon does to Earth, Proxima Centauri has only 18% the mass of the Sun and produces much less light.
Only
5% of the Sun's light reaches Proxima B, which may appear as a burned-out desert. However, there could still be liquid water if the planet has an atmosphere capable of retaining heat. The total energy it receives is about 65% of what Earth receives. Though it may not be a particularly welcoming place for life, it remains the best-known candidate due to its tidal locking, which results in one side always facing the star, creating a permanent day and night cycle. Additionally, Proxima B receives nearly 3 times more intense radiation than Earth, including ultraviolet light and X-rays. Its proximity to Proxima Centauri subjects it to frequent solar flares unless it possesses a protective magnetic field. Despite these challenges, the conditions on Proxima B might still allow for life, although in unsettling or unexpected forms. Models suggest it could still be an inviting world. Atmospheres that are clean. Planets that are locked may experience rapid breakdown as a result of the loss of volatile gases on their night side. The atmosphere of the planet can be refilled by planetary and volcanic activity. This is possible. In the presence of strong magnetic fields, the atmosphere has a lower chance of escaping because we lack substantial information on Proxima B's volcanic activity or magnetic field strength. We cannot determine with certainty whether the planet has an atmosphere, but the presence of one suggests that seas may exist, and both together suggest that there is a lot of hope for life there. To find out if Proxima B possesses a complex biosphere, with the possibility of solar-powered charging stations spread throughout the day side to generate energy, lighting, and warming, the side facing the night must be examined. Otherwise, it would be too dark and cold for comfortable housing. The discovery of Proxima B has sparked a rush to determine if it crosses its star's face as seen from Earth. These transits would allow scientists to determine the planet's size and mass, enabling them to assess its density and confirm its rocky composition. This would provide information about the materials covering its surface. Starlight could pass through the planet's atmosphere during a transit. However, the likelihood that the orbit is in the ideal position for scientists to observe a transit is only 1.5%. The tendency of the star to erupt adds more difficulties. Astronomer David Kipping of Columbia University states that the star is unstable. Solar flares can absorb a rocky planet or reflect sunlight into infrared light. However, rocky planets produce a particular kind of infrared light when orbiting stars like Proxima Centauri. Moreover, the James Webb Space Telescope was designed specifically to detect infrared light. Proxima B's infrared signature is crucial for determining the planet's atmosphere, and the JWST's infrared capabilities are vastly superior. This may make it possible for the telescope to detect city lights on the night side of Proxima B, even if they are as weak as those on Earth. The JWST is capable of recognizing artificial lighting if it is confined to a frequency band much narrower than the star's light. Proxima B's dayside may be heavily surrounded by solar panels reflecting sunlight. As Proxima B orbits its star, it experiences a consistent pattern of day and night, with stark temperature variations. The temperature difference between day and night will depend on whether the entire planet is made of exposed rock or if it has an atmosphere. If there is no atmosphere, Proxima B's temperatures will change dramatically. The day side will radiate all of its received energy from Proxima Centauri as blackbody radiation. The night side, on the other hand, would appear as a frozen desert. If the temperature contrast between day and night is less pronounced, we can deduce the presence of an atmosphere. It will take the JWST just 11.2 Earth days to collect sufficient data to identify Proxima B's first artificial city lights. These nightside lights could prove that intelligent life exists beyond our solar system. In light of the study's findings, Proxima B may contain hidden information. Perhaps its daytime produces a lot of solar energy. The lights could offer evidence of a vibrant and technologically advanced society. The presence of synthetic lighting on Proxima B would be a groundbreaking discovery. Scientists are cautiously pursuing this discovery. These lights may indicate an advanced civilization, but there are numerous alternative explanations for such signals. The technology that the James Webb Space Telescope uses is still in its infancy, and astronomers are just beginning to refine their methods. The lights detected could be natural phenomena, reflections from surface features, volcanic eruptions, lightning storms, or even unusual atmospheric events that mimic artificial lighting. It is critical for scientists to continue their research and cross-check findings. In fact, the James Webb Space Telescope will continue observing Proxima B, as well as other potentially habitable exoplanets, to develop a deeper understanding of their atmospheres and surface conditions. The detection of artificial lights would be followed by years of further exploration to confirm their origins. If the signals do indeed originate from intelligent life, it would represent one of the most profound scientific discoveries in human history. The excitement surrounding Proxima B and other exoplanets stems not only from the hope of finding life, but also from the broader philosophical questions it raises about humanity's place in the cosmos. The discovery of alien civilizations would force us to reconsider the uniqueness of life on Earth. It could lead to an era of unprecedented cooperation among nations. The discovery of alien life would unite humanity with a shared sense of curiosity and awe. It would also underscore the importance of space exploration, prompting us to invest in new technologies that allow us to continue searching for answers in the farthest reaches of the universe. The search for city lights on Proxima B serves as a tantalizing possibility, one that may soon reveal whether we are truly alone in the universe. As the James Webb Space Telescope sends back more data, the dream of finding signs of intelligent life beyond Earth becomes more tangible, bringing us closer to answering one of the greatest questions of all time: whether or not Proxima B possesses this advanced civilization. Its discovery could be the key to unlocking the future of space exploration and interstellar communication. As we keep pushing the boundaries of what is feasible for the next generation of astronomers, scientists, and explorers, we may be the ones to verify what was once thought to be impossible: that life, in all its various forms, is more prevalent than we ever imagined.